Hey guys, let's see how we can solve question 62 from the second chapter of the Beer&Johnston textbook. And we have this movable bin and its contents that have a combined weight of 2.8 kilonewtons. We need to determine the shortest chain sling ACB. It can be used to lift the loaded bin if the tension in the chain is not to exceed 5 kilonewtons. So if we want to draw the free body diagram of point C, what we're going to have in here, we have the two chains that are attached at point C. We can call each of them T, and we know this T cannot exceed 5 kilonewtons. And obviously we have the force in the top of the point C, which we can call it force F. And since we are in equilibrium, the sum of all forces has to be 0. But if you look at this, we'll see that in order to do the equilibrium equations for point C, we need to figure out the force F in here. And the way we're going to find the force F is that we're going to look at the whole system. And if we try to draw the free body diagram for the whole system, we basically have this force F in here and the weight of this load, which is 2.8 kilonewton. So if we do our equilibrium equations for the whole system, we'll see that we only have forces in y direction if we call our x and y this direction. So this will be our positive y. We basically have F minus W is equal to 0, which means our F is basically W. So the F that we have in the free body diagram of joint C is basically our W. Now we're good to go to use our equilibrium equation for the free body diagram of point C. And because of the symmetry of the system, if we call this angle theta in here, this one would be theta 2. So we're going to do the same thing if we do sum of all forces in y direction equals 0. We know the maximum the tension in the chain is 5 kilonewtons. So basically we have F or W minus T sine of theta, which would be our y component. So basically we are dissolving our T into two different components of x and y, and we have 2T. So we're going to have 2. So minus T sine of theta is equal to 0. So here our weight is equal to 2T sine of theta, or our sine of theta is equal to W over 2T. So our weight is 2.8 kilonewton. The tension from the question we know cannot exceed 5, so 2 times 5. And they're both in kilonewton, so it will be cancelled out. So if we want to find our theta, we basically have sine inverse of 2.8 divided by 10, which is 0.28. And let's calculate this. That's going to give us 16.26 degrees, and that would be the angle theta in here. So now that we have the angles theta, what the question is asking is the length of ACB. So this is our A, this is C, and this will be our B. Basically, if we divide this into two different right triangles, we basically, so ACB is equal to AC plus CB, which because of the symmetry, again, they are the same. So we basically have 2 times AC. Let's see how we can find AC. So we know the whole distance here to here is 1.2, which means each of these are 0.6 meter. So we know cosine of theta is 0.6 over AC. So our AC is basically 0.6 divided by cosine of theta. So we have 2 times 0.6 divided by cosine of 16.26 degrees. And if we want to find the length of ACB, which is the answer for this question, all we need to do is just to 2 times 0.6, 1.2 divided by cosine of 16.26. So that's going to give us 1.24, 1.25 meter, which is the length that the question is asking. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next one.